Picture the coldest week of winter in a coastal Chinese city. It is below freezing outside. Inside, in 500,000 homes, in schools, in hospitals, the radiators are running hot. That part is normal. Here is the part that is not. Somewhere nearby, an entire fleet of coal-fired boilers that kept this exact city alive every winter for decades has gone quiet. Not idle for maintenance, gone for good. And the heat now running through those radiators never touched a single lump of coal. It came from a nuclear reactor roughly 130 kilometers away. This is not a concept video. This is not a government promise on a slide somewhere, and it is not a single lab demo dressed up to look bigger than it is. This is a city that has already lived through 6 full winters this way, with the coal, the emissions, and the square meters all published and checked every single season. And right now, the same company is building a pipeline long enough to do the exact same thing for a city of over 10 million people. 6 winters of real data, a coal-free city that already exists, and a target 10 times bigger already under construction. By the end of this video, you will understand exactly how you heat a city with a nuclear reactor, why almost nobody outside the energy industry is talking about it, and how big this could actually get. If you like videos about the technology quietly reshaping how the world works, hit like and subscribe so you do not miss what is coming. Let us start with the problem this was actually built to solve. Northern China has a heating season, and it is not optional. For decades, the government has drawn an invisible line across the map, roughly following the Huai River, and everything north of it gets centralized winter heating by law. Everything south of it does not. That line was drawn in the 1950s, based on how much coal the country could spare, and for 70 years, it has decided who gets warm and who shivers through the winter with space heaters. The system that grew up north of that line runs almost entirely on coal. Coal-fired boilers, sometimes decades old, burning around the clock for 4 or 5 months a year, piping hot water through citywide networks into apartment radiators. It works. It has kept hundreds of millions of people warm since before most of them were born. But every winter, it also does something else. It fills the air. You have probably seen the photos even if you did not know what caused them. Entire skylines in northern Chinese cities disappearing into a thick gray haze every December and January. Flights grounded. Schools closing because the air outside was rated hazardous. Here is the number that makes it make sense. At the end of 2016, coal was still meeting more than 80% of all heating demand in northern China, and the region was burning through roughly 400 million tons of coal every single year just to keep people warm. That is not counting coal used for electricity or industry. That is coal burned specifically so families could survive winter. Researchers have tied a measurable chunk of the region's worst seasonal smog directly to those boilers switching on the moment the temperature drops. This is not a hidden problem. It is one the Chinese government has openly admitted to for years, which is exactly why in 2017 it rolled out a national clean winter heating plan, targeting a cut of 150 million tons of heating coal within 5 years, and explicitly naming nuclear energy, alongside natural gas, electric heat pumps, and geothermal, as an acceptable replacement. On paper, that sounds simple. In practice, it was not. When local governments pushed families to switch from coal stoves to gas, household heating bills jumped by somewhere between 1,000 and 2,000 yuan a year, and in some regions the rollout moved so fast that people were left with brand new gas hookups and no gas actually available yet, in the middle of winter. Clean heating turned out to be easy to mandate and expensive to deliver. So the real question was never whether China wanted to get off coal heating. It clearly did. The question was, what could replace an entire regional heating system without making winter more expensive for hundreds of millions of people, and without depending on imported gas? And the answer that nobody expected came from a place already sitting on the coast, already running, already producing more heat than it knew what to do with. Here is something almost nobody thinks about. Every power plant on Earth, coal, gas, or nuclear, works the same basic way. You boil water, the steam spins a turbine. The turbine makes electricity. And in every single one of those plants, most of the heat you started with never becomes electricity at all. It gets dumped straight into a river, a lake, or the open ocean as waste. A typical nuclear plant converts roughly a third of its heat into electricity and throws away the rest through its cooling system. That is not a flaw. That is just how turbines work. It has been true since the 1880s. Now think about where a lot of these plants are actually built. On the coast, next to cold seawater used for cooling, and often not far from a city that needs heat for 5 months out of every year. For 100 years, that heat just poured into the ocean and nobody thought twice about it. The plant made electricity, and everything else was waste. On the coast of the Yellow Sea, in Shandong Province, State Power Investment Corporation, one of China's biggest state-owned energy companies, was running exactly that kind of plant. Haiyang Nuclear Power Plant, 2 Westinghouse-designed AP1000 reactors, switched on in October 2018 and January 2019, together putting out around 20 billion kilowatt-hours of electricity a year onto the regional grid. A serious, modern, 2.5 gigawatt facility. And somebody at the company running it looked at all that wasted heat pouring into the sea and looked at the coal boilers keeping the nearby city warm every winter and asked an obvious question that somehow nobody had seriously acted on before at this scale. What if the reactor heated the city directly instead? The idea sounds almost too simple, and that is exactly why it took decades for anyone to build it properly. Inside a pressurized water reactor like the ones at Haiyang, there are 2 separate loops of water that never touch each other. The primary loop runs through the reactor core itself, picks up heat, and is kept under enough pressure to stay liquid at extreme temperatures. That water is the only part of the plant that ever comes near the nuclear fuel, and it never leaves a sealed, heavily shielded circuit. That primary loop passes its heat into a second loop through a steam generator without the water itself ever mixing. This secondary loop is the one that actually spins the turbine. Crucially, this steam is not radioactive. It has never been anywhere near the reactor core. It has simply absorbed heat through a metal wall. At Haiyang, engineers built a system to pull a portion of that non-radioactive secondary steam off before it fully finishes its normal job, and route it through its own dedicated heat exchange station on the plant site. There, the heat gets passed through yet another wall into a completely separate, closed loop of water that belongs entirely to the city's heating network, run by a local partner called Fengyuan Thermal Power. That water never enters the plant at all. It just picks up heat at the exchange station and carries it out through ordinary municipal pipes, the same pipes any coal-fired heating plant would have used, into apartment radiators across the city. Count the walls between the nuclear fuel and your living room radiator. The reactor core sits inside the primary loop. The primary loop hands off heat, never water, to the secondary loop. The secondary loop hands off heat, never water, to the secondary loop. The secondary loop hands off heat, never water, into your building's own internal system. 4 separate sealed loops, 3 heat exchanges, and at no point does a single molecule that touched the reactor core ever travel toward a home. It is less like plumbing and more like a very long, very careful relay race, where every runner is only allowed to pass the baton, never touch the next runner's hand. This is usually the exact moment someone watching starts to worry, and it is a fair thing to worry about. Nobody wants radioactive water anywhere near their radiator. But that is precisely the question this design was built to answer before the first pipe was ever laid. The steam being extracted for heating comes from the secondary loop, the same loop that spins the turbine to make electricity, and it has never been inside the reactor vessel or in contact with the fuel rods. It is, functionally, just very clean, very hot water vapor. The heating loop that actually reaches your building is a third, completely separate system again. 3 walls of separation between the fuel and your radiator is not a marketing claim. It is the entire engineering premise the project would collapse without, and it is why regulators allowed it to be built next to an active city in the first place. Haiyang did not attempt this all at once. It grew a piece at a time, and that slow, deliberate rollout is exactly why the numbers behind it are trustworthy instead of just a press release. In the winter of 2019, the plant ran a trial. Just 700,000 square meters of heating, roughly enough for a few thousand apartments, covering the plant's own worker dormitories and a handful of nearby residential buildings. It was a proof of concept, nothing more, and it worked exactly as engineered. By November 2020, the trial became commercial. The city gave the network its own name, Nuanhe 1, which roughly translates to Warm Core Number 1. And in November 2021, Phase 2 expanded the coverage to 5.2 million square meters, enough to cover the entire city of Haiyang. 12 separate coal-fired boilers across the city were switched off and never turned back on. Around 200,000 residents were now getting their winter heat from a nuclear reactor instead of a smokestack. Haiyang became, officially, China's first zero-carbon residential heating city. Then the network started reaching past the city limits. Rushan connected next, bringing the population served past 1 million people. In November 2025, the city of Rongcheng became the third settlement added to the grid, using a new technique the company calls dual-unit series heating, where 2 reactor units are connected in sequence so the water passes through both, picking up more heat along the way before it ever leaves the plant. That single expansion alone was projected to cut coal use by another 120,000 tons a year. By the end of its 6th full heating season, the network covered nearly 13 million square meters, and total heating capacity had grown from that original 31.5 megawatts in 2019 to 1,134 megawatts. Across 6 winters, the project has supplied clean warmth to roughly 400,000 households across Haiyang and Rushan combined. Notice the shape of that growth. This was never announced as a finished system on day 1. It was tested small, on a dormitory, then expanded to a whole city, with every one of its coal boilers physically decommissioned, then stretched to a second city, then a third, each time with the previous winter's numbers published first, and each expansion using slightly more sophisticated engineering than the last. That is not how a government demonstration project usually behaves. That is how a company behaves when something is actually working and it wants the data to prove it before asking for the money to go bigger. Here is where the story stops being a nice idea and starts being a measurable fact. Across its first 5 full winters of operation, the Haiyang heating network delivered 9.01 million gigajoules of heat to homes and buildings. In doing that, it displaced roughly 810,000 tons of coal that would otherwise have been burned in local boilers, and cut carbon dioxide emissions by about 1.49 million tons. In just the most recent season alone, the network avoided another 410,000 tons of coal and roughly 760,000 tons of carbon dioxide in a single winter. Coal is not just a carbon problem. Burning it for heat also puts nitrogen oxides, sulfur dioxide, and soot straight into the air people are breathing during the exact weeks when everyone is stuck indoors with the windows shut. Local officials in Haiyang have reported measurably improved winter air quality since the coal boilers went offline. And there is one detail almost nobody mentions, because it sounds too small to matter until you realize what it represents. The patch of sea around the plant that used to run about 2 degrees Celsius warmer than normal, because of waste heat being dumped straight into the ocean from the plant's cooling system, has shrunk by 41 hectares since the heating scheme began. That heat is not gone. It did not disappear. It got redirected out of the ocean and into people's homes instead. Everything up to this point covers a city of a few 100,000 people. Here is where the scale changes completely. The Jiaodong Peninsula, the stretch of Shandong coastline where Haiyang sits, is also home to Yantai, Weihai, and Qingdao, one of the most economically important regions in the entire province. Qingdao alone has a population north of 10 million people. State Power Investment Corporation has publicly targeted 2026 to begin extending nuclear heat to Qingdao, using a long-distance heating pipeline running roughly 100 kilometers from the plant. The company's long-term plan for the full Haiyang network is 200 million square meters of heating coverage, enough to eventually serve around 5 million people across the region, a target that would make this single nuclear plant responsible for keeping more people warm every winter than the entire population of Norway. None of that scale is possible with just the 2 original reactors. 2 additional units, upgraded Chinese-designed CAP-1000 reactors based on the same AP-1000 technology, are already under construction at the site, with construction starting in 2022 and 2023. 2 more units received official construction approval in 2026. Up to 6 reactors total are now planned for the site, and each new unit means more spare heat available to push further down the pipeline toward Qingdao. State Power Investment Corporation already calls Haiyang the world's largest nuclear cogeneration heating project in operation, and every new reactor at the site makes that gap between Haiyang and everyone else even wider. None of this would have scaled past a single demonstration project if it only worked as a climate gesture. What actually pushed it from a pilot to a 6-winter commercial network is money, and the math is almost embarrassingly simple once you see it laid out. A coal-fired district heating boiler has to buy coal, every single day, all winter, and coal prices move with the market. A gas-fired system has to buy gas, and as northern China found out the hard way during the first rushed rollout of the clean winter heating plan, imported gas prices can spike right when demand is highest, leaving cities scrambling and households facing bills 1,000 yuan or more, higher than the coal system they just gave up. A nuclear reactor, by comparison, is already running, already generating electricity around the clock regardless of the season, and the heat being extracted for the city was previously being thrown away for free. There is no additional fuel cost for the heat itself. The only real expense is building the pipeline once, and after that, the marginal cost of warming another building is close to nothing. That is also why the city did not have to rip out its existing infrastructure to switch over. The hot water still flows through the same municipal pipes that used to carry coal-heated water. The only thing that changed is what is heating the water at the source. From the perspective of a family in Haiyang, nothing about their radiator changed at all. The bill did not go up. The pipes did not change. The only difference is that the boiler 12 blocks away that used to burn coal all winter simply stopped running. It would be dishonest to make this sound like a solved problem the rest of the world just has not noticed yet. So let us talk about why this has not already happened everywhere. Heat does not travel the way electricity does. You can send electricity thousands of kilometers down a wire with manageable losses. Push hot water through a pipe over the same distance, and you lose a meaningful chunk of that heat to the ground and the air along the way, on top of the enormous upfront cost of laying the pipeline itself. That is why every phase of this project has crept outward gradually, city by city, rather than jumping straight to Qingdao from day one. The 100-kilometer pipeline being built now is close to the practical limit of what makes economic sense for this kind of system, and even that required years of smaller-scale success first to justify the investment. This also only works at all if you already have a large, modern reactor sitting near a city that needs heating for months at a time. Most nuclear plants on Earth were never built with this in mind, and retrofitting an existing reactor for large-scale heat extraction is not something you casually bolt on afterward. It has to be part of the design, or close to it, from early on. That limits how fast this can spread, even inside China, let alone anywhere else. And it is worth being honest about the scale of the piece this actually addresses. China's northern heating season burns an enormous amount of coal every single winter, across hundreds of cities. Haiyang's network, even at its full planned size covering 5 million people, is still a small fraction of that total demand. This is not a story about nuclear power replacing coal heating everywhere overnight. It is a story about a working, replicable model finally existing at real commercial scale, in a country with both the coastline full of nuclear plants and the political will to build the pipelines fast. China is not the first country to try heating homes with a nuclear reactor. Russia, Switzerland, Sweden, and a handful of Eastern European countries have run smaller nuclear district heating schemes for years, some going back decades, usually attached to a single reactor warming a single mid-sized town. What none of them ever did was build one at this scale, monitor it publicly across 6 full winters, publish the coal and emissions numbers every single season, and then immediately start laying pipe toward a city of 10 million people. That combination of transparency, speed, and ambition is the part that is actually new here. It is also worth remembering the scale this still needs to grow into. Northern China burns roughly 400 million tons of coal a year for heat. Even at its full long-term target of 200 million square meters covering 5 million people, Haiyang's network would still only be a small slice of that national total. This is not a story about nuclear heat replacing coal everywhere overnight. It is a story about the first fully proven, fully commercial template for doing it, existing at last, in a country with dozens of coastal nuclear plants and the political will to keep laying pipeline. The International Atomic Energy Agency highlighted the Haiyang project in December 2025 as a working model for carbon-free heating, and China's own nuclear industry has already signaled where this template goes next. The World Nuclear Association has noted plans for similar district heating offtake at other Chinese plants, including the CAP 1400 reactor under construction elsewhere in Shandong, and at existing plants at Qinshan, Tianwan, and Hongyanhe. Longer term, Chinese nuclear engineers are already looking past today's reactors entirely. Toward fast neutron reactor designs, they expect to become the dominant technology for exactly this kind of combined power and heat production by the middle of the century. Step back and look at what actually happened here. A power plant that used to dump most of its heat into the ocean as pure waste is now the primary heat source for an entire coal-free city, with a pipeline under construction to do the same thing for a metropolis of 10 million people, using heat that was, for the plant's entire first year of operation, simply thrown away. That is not a hypothetical clean energy pitch. That is 6 winters of measured coal displaced, measured emissions avoided, and measured square meters of housing kept warm without a single coal boiler running. For most of the last century, a power plant's job ended the moment electricity left the building. Everything else, all that leftover heat, was just the cost of doing business. Haiyang is a bet that the leftover half of the equation was never actually waste. It was just heat nobody had bothered to pipe anywhere yet. If this video showed you a piece of the energy world you had not heard about before, hit like, subscribe, and turn on notifications so you catch the next one. And here is a question for the comments. If a reactor's wasted heat alone is enough to keep a city of hundreds of thousands warm through winter, how many power plants near you, coal, gas, or nuclear, do you think are dumping that exact same amount of heat straight into a river or the ocean right now?